Hello friends, in the last class we have solved the exercise third of first chapter and I think till question number 16 we have solved. Now let us solve the further question. Next question, that is question number 17. Okay, question number 17 is like this. A function f from R to R defined by the formula f of x is equal to x upon x square plus 1, okay, is given, and you have to show that this function is neither 1 nor untrue. Okay, so let us show this that this is neither 1 nor untrue. Okay, so first we will check the 1-ness or injectivity. Okay, for checking injectivity we will take two elements in the domain. Let x and y belongs to R, that is domain, such that f of x is equal to f of y, and therefore putting the formula x upon x square plus 1 is equal to y upon y square plus 1. Therefore xy square plus x is equal to x square y plus y. Therefore xy square minus x square y plus x minus y equal to 0. Let us further simplify. We will take xy common from the first two terms. So taking xy common we will get y minus x, and from the second term we will take minus 1 common, which will be y minus x, and therefore we have xy minus 1 into y minus x is equal to 0. Therefore xy minus 1 is equal to 0, or y minus x is equal to 0, and therefore y is equals to 1 by x, or y is equals to x. Okay, what does this mean? This means that for the two different elements in the domain 1 by x and x, we have the same image y in the codomain. It means for two different elements have the same image, it means this is a many-one function, and therefore f is many-one, or it is not an injective map. Please note down this. Then we will discuss the subjectivity. Okay, now let us see. Let us check the subjectivity for the same function. Subjectivity. Okay, let y belongs to R, that is codomain, such that f of x is equal to y, and therefore x upon x square plus 1 equal to y. On simplification we will get x is equal to y x square plus y, and finally y x square minus x plus y is equal to 0. Now you will notice that this is a quadratic equation in x, and now we will find, to check the nature of roots or values of x, we will find out the discriminant. So let us find out discriminant. D is equal to b square minus 4ac. Okay, here we know that a is y, b is minus 1, and c is y. Putting these values we get minus 1 the whole square minus 4 into y square. Therefore d is equals to Now, if you take the value, whole number values, any whether positive or negative from the domain to codomain is also R. But if we take only integers, whether positive or negative integers, and put here, you will notice that this discriminant will be negative. Yes or no? So now this will be negative for all integers except 0. If you put over here 0, it is you will have real roots because d is equal to 1, which is greater than 0. But for less, if you take the integers positive, negative other than 0, then obviously this will be an imaginary number. So it simply means that you don't have the real images for the positive or negative integers. Clear? And therefore codomain and range will be different, and therefore range of f is not equal to its codomain, and therefore f is not onto, or it is not surjective. Now since it is not 1 1 as well as it is not onto, therefore this function is not bijective, and therefore f is not biject. Please note down. Set A R minus 3 and set B R minus 1 are given. Okay, a function f from set A to B is defined by the formula f of x is equal to x minus 2 upon x minus 3. We have to show that this is 1 1 and onto, that is this is bijective, and then we have to find f inverse. So first let us show that this is bijective. So for that first we will check injectivity. Okay, let x and y belongs to set A, that is domain, such that f of x is equal to f of y. Therefore x minus 2 upon x minus 3 is equal to y minus 2 upon y minus 3. Therefore xy minus 3x xy minus 3x minus 2y plus 6 is equal to xy minus 2x minus 3y plus 6. Okay, if you simplify this xy and 6 will get cancelled. Again transpose 3y minus 3y, so 3y minus 2y y, and 3x minus 2x we will get x. So we got x is equal to y, and therefore we will write down that f is injective, or it is a one function. Now let us check the surjectivity. Okay, let y belongs to B codomain such that f of x is equal to y. Therefore x minus 2 upon x minus 3 is equal to y. Therefore x minus 2 is equal to xy minus 3y. Okay, and therefore y minus 2 is equal to xy minus x. Therefore 3y minus 2 is equal to, take x common, we get y minus 1. Now making x the subject, we get x is equal to 3y minus 2 upon y minus 1. Obviously, for all y belongs to codomain B, we have all x belongs to domain. So here we will write down. So for all y belongs to codomain, we have x belongs to domain set A, and therefore f is surjective, and hence since f is both injective and surjective, and therefore it is a bijective function. Please make a note. Okay, question number 19 and 20 are similar. Okay, here we have to find f inverse, we will find out, no problem. Then question number 19 and 20 you will solve yourself. I will solve the 20 first, but before that let us find out the f inverse. Okay, now we know that the function f is a bijective function, therefore f inverse is equal to x. F inverse is equal to I, and therefore f inverse of x is equal to I of x, and therefore f inverse x is equal to x. Therefore in the formula of function f, let us put for x f inverse x. Okay, so f inverse x minus 2 upon f inverse x minus 3 is equal to x. On simplification we will get f inverse x minus 2 is equal to x into f inverse x minus 3x. Okay, and therefore x minus 2 is equal to x is into f inverse x minus f inverse x. Take f inverse x and common and make it the subject, so you will get 3x minus 2 is equal to, taking first f inverse x common, will get x minus 1, and finally f inverse x is equal to 3x minus 2 upon x minus 1. So this is the inverse. Easier method is put f of x is equals to y and make x the subject. Okay, and after making x the subject you will get a term similar to this, like this. We will get x is equals to 3y minus 2 upon x minus 1. Then replace x by f inverse y. So you will get this equation, and finally if you substitute for y x, we will get f, the same one, f inverse x is equal to 3x minus 2 upon x minus 1. So both the ways you can solve. I think this will be easier. Okay, putting y for f of x and making x the subject, then substituting for y x. Please note down. Okay, so 19 and 20 are similar questions. So you will try yourself. Now let us solve question number 21. question number 21. F from n to n is defined by f of x is equal to x plus 1 and x minus 1 x plus 1 if x is odd and x minus 1 if x is even. We have to show that this is a bijective function. So we will check both one and ontoness. So first let us check the oneness or injectivity. Okay, for this we will take two elements. Now suppose we are taking two elements x and y in the domain and set of natural numbers such that both are odd. Here we have three possibilities. X and y both are odd, number 1. Number 2, x and y both are even. And number 3, one is odd and one is even. So we will consider all these three cases. So case 1, let x and y both are even. First let us take both are even. Okay, then f of x is equals to f of y. Now if x and y both are even, then we will put the value in this formula. Okay, x minus 1. So x minus 1 is equal to y minus 1 and therefore we will get x is equal to y. Okay, now case 2. Let x, y both are odd. Then we have formula for odd. X, okay, f of x is equals to f of y and therefore x plus 1 is equal to y plus 1 and therefore x is equal to y. Okay, and the third case, case 3, if x is odd and y is even, or reverse of that, x is even, y is odd. Okay, in both these cases obviously x is not equal to y because x is even and y is odd, or x is odd, y is even, and therefore f of x will not be equal to f of y. Okay, and therefore this function will be one function. So in all these three cases, okay, so therefore in all three cases we have proved that f is 1 1. F is 1 1. We have proved. Okay, here you may note down. Here also. Okay, and here also f is 1 1. So in all the three cases we have proved that f is a one-to-one function and therefore it is an injective map. Note down, afterwards we will discuss the surjective. Here also you may write down that f is 1 to 1. Okay, now let us discuss the surjectivity. Okay, now let us consider that suppose x is odd and then we will consider that x is even. Okay, number 1. If suppose x is odd, then x plus 1 will also be an odd number. Yes or no? Oh, sorry, x minus 1 will also be an odd number. If x is odd, then x okay, if x is odd, then x plus 1 will be even. If you add 1 to any odd number, it will become even. Okay, so if x is odd, then x plus 1 is even, and therefore f of x plus 1. So you put the value this in the formula for even. So this is the formula. So x plus 1 minus 1 is equal to, we will get x. Clear? So when x is odd, okay, we got f of x plus 1 is equal to x. Now if x is even, in that case x minus 1 will be odd. Yes or no? Because from even number, if you subtract 1, you will get an odd number, and therefore let us find out f of x minus 1. The formula for odd is x plus 1. So here for x you put x minus 1. So x minus 1 plus 1 is equal to x. Clear? So for all the numbers, whether even or odd, we have a value x which belongs to the domain, codomain. Yes or no? And therefore this function is a surjective function, and therefore for all x belongs to domain, we have f of x which belongs to, or for all f of x belongs to, we should write for all f of x belongs to codomain, we have x belongs to domain, and therefore f is surjective. Now since injectivity we have already proved, so since this function f is both injective and surjective, and therefore f is bijective. Please note down. Since f is injective and surjective both, and therefore f is a bijective function. Please note down this answer. Okay, question number 22 is similar to this, only the domain and codomain are changed from n to n to w to w, means whole number to whole number, and the definition of the function is changed. For even it is given now x plus 1, and for odd it is given x minus 1. So you will follow the similar steps to solve. Okay, question number 2. Now I will solve question number 23. X plus 1 by 2 and x by 2 given. Okay, this is question number 23. Yes, it is question number 23. bijective function, obviously we will check injectivity and surjectivity. If it is both, then it is bijective, and if it is suppose it is not 1 1 or it is not on 2, then it is not a bijective function. Let us check first injectivity. Okay, now for injectivity, we will explain the injectivity with the help of example. It will be easier for us. Okay, for example, for x is equal to 1. 1 is an odd number. F of x will be 1 plus 1 by 2 is equal to 1. And for x is equals to 2, 2 is even, so put the value of x in the formula for even. So f of x will be 2 by 2 is equal to 1. So f of 1 and f of 2 both are 1. It means two different numbers in the domain have the same image in the codomain, that is 1, and therefore this is a many-one function. And therefore f of 1 is equal to f of 2, both are equal to 1, and therefore f is many 1, and therefore it is not bijective. It is sufficient to show that if it is not injective, then this will not be a bijective function, and therefore f is not bijective. Please note down. Okay, question number 24. A function f of x is equal to x minus 1 upon x plus 1. We have to verify, we have to first find the inverse, and then we have to verify that f of f inverse is an identity function. Okay, so let us first find out the inverse. Okay, so to find the inverse, we will put f of x is equal to y, that y belongs to codomain such that f of x is equal to y, and therefore x minus 1 upon x plus 1 is equal to y. Therefore x minus 1 is equal to xy plus y. Therefore x minus xy is equal to y plus 1. Therefore x into 1 minus y. Okay, therefore x is equal to y plus 1 upon 1 minus y. Now replace x by f inverse y, y plus 1 upon 1 minus y. Okay, so here we got the inverse of the function. Finally we will replace all the y with x. So f inverse x is equal to x plus 1 upon 1 minus x. This is the inverse of the function. Now we have to check that f inverse is an identity function. So note down. Afterwards we will check f of f inverse is equal to identity function. Okay, now we got f inverse. Now let us check whether f of f inverse is identity. So f of f inverse of x is equal to f of f inverse x is equal to, okay, now in the formula for the function we will put f inverse x, that is x. For x we will substitute x plus 1 upon 1 minus x. So let us substitute x plus 1 upon 1 minus x minus 1 upon x plus 1 upon 1 minus x plus 1. Let us simplify. So x plus 1 minus 1 plus x and x plus 1 plus 1 minus x. Okay, so here we will get 2x upon 2 is equal to x, and therefore f of f inverse of x is equal to Ix, and therefore f of f inverse is equal to I. Hence 2. Please note down. Okay, now a function, one more function is given, question number 25. A function f from r plus 2 4 to infinity, defined by the formula f of x is equal to x square plus 4. Okay, we have to show that this is a bijective function. Okay, so let us do that injectivity first. Okay, now let x and y belongs to R plus domain such that f of x is equal to f of y. Therefore, x square plus 4 is equal to y square plus 4, and therefore x square is equal to y square. Here the root will be only plus y because the value we have taken from R plus, and the codomain is from 4 to infinity. Okay, so x is equal to y, and therefore f is 1, 1. Okay, x and y both are in domain, and domain is R plus, so negative value we don't have to consider, and therefore f is 1, 1. Now let us check the surjectivity. Okay, for this we will consider one element y belongs to codomain such that f of x is equal to y. Therefore x square plus 4 is equal to y. Therefore x square is equal to y minus 4, and therefore x is for all y belongs to 4 to infinity. It is very clear. Okay, x will belong to the domain R plus. Okay, and therefore for all y belongs to codomain, we have x belongs to domain, that is R plus, and therefore f is on 2, or it is a surjective function. Okay, please note down. So we have proved that f is a bijective function. Now we have to find the inverse. Let us find out the inverse now. Now let f of x is equal to y, therefore x square plus 4 is equal to y, x square is equal to y minus 4, therefore x is equal to, therefore f inverse y is equal to, and finally f inverse x is equal to x minus 4. This is the inverse. Now, so up to now you must have understood that in the method of surjectivity, certain steps we are following which is common to the steps of finding the inverse. You can make a note of this. Okay, so this question is also clear. Now, the remaining questions we will solve in the next video. Okay, thank you very much. Okay, now let us solve question number 26. Question number 26 is like this. Function f from r plus 2 is codomain defined by f of x is equal to 5x square plus 6x minus 9 is given. We have to check the invertibility. It means whether the function is invertible or not. Now we know that a function is invertible if it is a bijection. It means it is both 1, 1 and 1, 2. So first we will check the bijectivity and then we will show that this is the inverse. F inverse y is equal to this given value. Clear? So let us first check the bijectivity. So first injectivity. Okay, let x and y belongs to domain R plus such that f of x is equal to f of y, and therefore 5x square plus 6x minus 9 is equal to 5y square plus 6y minus 9. Let us simplify. Therefore 5x square plus 5x square minus 5y square plus 6x minus 6y is equal to 0. Therefore 5 into x plus y into x minus y plus 6 into x minus y is equal to 0. Therefore x minus y into bracket 5x plus 5y plus 6 equal to 0. Now this bracket is never 0 for any value of x and y, and therefore putting this in the denominator, 0 upon bracket will be equal to 0, and therefore x minus y is equal to 0, and finally we get x is equal to y. So if f of x is equal to f of y, implied x is equal to y by the definition of the function, and therefore injective map, and therefore f is an injective map. Okay, or it is a 1-1 function. Please note down, then we will check the surjectivity. Okay, now let us check surjectivity, that is ontoness. Okay, here let y belongs to codomain such that f of x is equal to y. Therefore 5x square plus 6x minus 9 equal to y. Therefore 5x square plus 6x minus y plus 9 is equal to 0. Obviously this is a quadratic equation in x. So let us first check the nature of roots. Okay, so a5, b6 and c equal to minus into bracket y plus 9. Therefore d discriminant is equal to b square minus 4ac is equal to 6 square, that is 36, minus minus plus 4 into 5 into y plus 9 is equal to 36. 5 4s are 20, 9s are 180, plus 20y. Okay, obviously 180 plus 36 is 216 plus 20y. This will always be greater than or equal to 0. Okay, this will always be equal to greater than 0 for any value of y from the codomain. Even if you put minus 9, so 216 minus 180 will be greater than 0, and therefore for all y belongs to codomain, we have x belongs to domain, and therefore f is surjective map, or it is a surjective function. Now since f is both injective and surjective, therefore it is bijective, and therefore f is bijective, and therefore f is invertible. Please note down. Then we will prove, the next step is to prove that f inverse y equal to the given expression. Okay, now let y belongs to codomain such that f of x is equal to y. Therefore 5x square plus 6x minus 9 equal to y, and therefore 5x square plus 6x minus y plus 9 equal to 0. And now we know that since for all the values of y, the x will have real values, and therefore x is equal to minus b plus or minus square root of b upon 2a equal to minus 6 plus or minus square root of d is 216 plus 20y upon 5 into 2. Okay, now let us simplify. Now obviously if you take minus and value over here, if you consider, then the root will become minus, but since the domain is r plus, we cannot take minus values, and therefore we will consider only plus one. Okay, therefore x is equal to minus 6 plus, okay, from both the terms if you take 4 common, so square root of 4 will be equal to 2, and inside the bracket is left 5y plus 54 upon 5 into 2. On further simplification we will get x is equal to minus 3 plus 5y plus 54 upon 5, which is the required. Okay, finally we will substitute x with f inverse y. So f inverse y will be equal to minus 3 plus square root of 5y plus 54 upon 5. Please note down. Okay, now in this exercise, question numbers 27, 28 and 29, this kind of sums we have done earlier in this same exercise. I think 3 or 4 questions of the same types we have already solved, so we will not solve the next 3 questions. Now the last question of this exercise, that is question number 30, I will solve for you. Okay, now question number 30. Function f from whole number to whole number given by the formula f of x is equal to x plus 1, x minus 1 if x is even and if x is odd. We have to show that f is invertible and we have to find the inverse. Now invertibility we have already checked, it seems, but still once again we will check for this question. Okay, so injectivity first. Let x and y belongs to domain. From the domain we take 2 elements. Now 3 cases arise. X and y both are even, x and y both are odd, and one is even and one is odd. So all the 3 cases we should discuss. Case 1, if x and y both are even, okay, in that case x f of x is equals to f of y implies x plus 1 is equal to y plus 1, therefore x is equal to y implies f is 1 1. Now let us discuss case 2. If x and y both are odd, okay, in that case again f of x will be equal to f of y will imply x minus 1 is equal to y minus 1 will imply x is equal to y. It implies again f is 1 1. Okay, now case 3. If x is even and y is odd or the reverse. Okay, so if x is even and y is odd, or y is odd, x is even, in both these cases x will not be equal to y. It will imply f of x will not be equal to f of y. Clear? And therefore f is 1 1. So in all these 3 cases we have proved that f is 1 1 and therefore f is an injective mat. Please note down. Okay, now we will check surjectivity. suppose x is an odd number, then x minus 1 will be even. Yes or no? If x is odd, then on subtracting 1 from the odd number, you will get an even number, and therefore f of x minus 1 is the image of x minus 1 for x even. If you put the formula value in place of x, x minus 1, we will get x. Yes or no? X minus 1 plus 1. And if x is even, then x plus 1 is odd, and therefore f of x plus 1. Okay, on substituting x plus 1 for x over here, again we get f of x plus 1 is equal to x. It simply means if x is even, then the answer will be odd, and if x is odd, then the answer will be even. Okay, and therefore for all f of x belongs to codomain, we have x belongs to set of whole numbers, that is domain, and therefore f is an onto function, and hence it is invertible, and therefore f is invertible. Why? Because it is both 1 1 and on. Please note down. Okay, now finally we will find out the inverse in both the cases. Okay, now if x is even, that y is equal to f of x, therefore y is equal to x plus 1, therefore x is equal to y minus 1, therefore f inverse y is equal to y minus 1, and if x is odd, and let y is equal to f of x, therefore y is equal to x minus 1, therefore x is equal to y plus 1, therefore f inverse y is equal to y plus 1. So we have got the inverses for both the cases. If x is even, therefore if x is even, finally we will substitute. For y we will substitute x in both these cases. So if x is even, then f inverse x is equal to x minus 1, and if x is odd, then f inverse x is equal to x plus 1. Okay, please note down. Now in your new textbook, exercise 3 of chapter 1 is completely over. The next exercise we will start in the next video. Okay, thank you.